Here I have a Super Mario Nintendo Switch controller. And as we can see, this is an item that has originally been returned, and apparently it has no power. This came to me in an electronic slot that was originally sold by Argos, but was returned by the original buyer. It's been sat on the shelf for a while now, so it's about time I crack it open, see if what this sticker says is correct, and have a go at getting it working again. I have looked at customer returns in the past, and you do get lucky sometimes, where someone's returned an item claiming it's faulty just because they've changed their mind. Well, obviously that wouldn't make a particularly interesting video. Let's just get this box moved out of the way. And now we can start taking a look at the controller. I have to say it is quite a nice looking controller. Got a nice little Mario design on there. Let's just plug it in and give it a quick check, just to verify that it definitely doesn't work. I don't have a Nintendo Switch, so I'm going to test this by plugging it into a PC, see whether the battery starts charging when it's plugged in, and whether the PC detects it at all. Yeah, it's definitely not working. There's no LEDs lighting up, no activity on the PC. Okay, so let's crack this open then and take a look inside. Just removing the last couple of screws now, and then the two plastic parts either side need to be taken off, and then the controller should easily come apart. So now I've got the shell open, I'm just going to put the front half to one side. And the first thing that strikes me with this is just how tiny that battery is. I'll just bring this closer so that the view of the board's a bit clearer. So I can see wires going from the battery into the board, but it also looks like the shoulder buttons are soldered to the motherboard. So instead of using those flexible kind of contacts you see in something like a PS4 controller, they've actually used a small PCB for each side. I'm not entirely sure how this top part comes off, but hopefully I should be able to get into the wires for the battery, maybe without having to take this off. Maybe the entire board needs to come out of the shell for this part to come out. There's a couple of screws I'm going to remove now, which will hopefully allow the entire PCB to be removed from the shell. So let's try taking this board out now, see if it will come free. Yeah, I think it's coming out. There we go, that's got it. It's interesting, there's another little PCB in here, which is used for the D-pad contacts by the looks of it. Seems a bit odd to me, but that's how they chose to design it. Found another couple of screws here which need to be removed, and hopefully this will allow me to remove the shoulder button assembly. And with that out of the way, I've got much better access to these battery contacts, so I can measure the voltage of the battery and remove it if necessary. I've got my multimeter out here, and now I'm just going to see if we've got any voltage at all coming from the battery. I think I'll take that as a no. We're getting no voltage from the battery. Could mean that the battery is bad. It could have been over discharged or discharged enough to trigger the battery protection circuitry. I've seen that quite commonly in PS4 controllers. In that case, sticking them in an external charger tends to bring them back. We'll be able to see a bit more about this battery once I've removed it from the board. Desoldering should be pretty straightforward, just need to make sure the iron's nice and hot before starting. Next, I want to remove this battery completely, so I'm just going to try and get something under here and try and release the battery from the sticky pad that's holding it in place. Not the cleanest, but not too difficult once the tool started to cut through the pad. Just need to pull these wires out and then the battery should come out completely. Now I know I already tested the battery voltage once, but I decided to test it again outside of the controller just to make sure. And yeah, it goes straight to 0, so this battery is definitely not happy. So what I've done here is I've peeled back the protective tape covering the protection circuit on the battery. And it goes without saying that you should be very careful handling lithium-ion batteries, and I wouldn't recommend anyone doing this, as short-circuiting the battery would be a major fire risk. Measuring the battery directly, we can see we're getting a voltage around 2.7, 2.8. which is low for a lithium-ion battery, and it suggests that the low voltage has triggered the protection circuit, and that's why we're getting 0 volts on the output terminals. It'd be very rare for a battery to actually have no voltage whatsoever, so if you see a 0 volt reading, it's a sign that that protection circuit has kicked in for some reason. I've soldered the battery wires to a JST connector so that I could plug it into an external charger. And there we can see the green light, which means the battery is charging. And from my experience, it's quite common that if you take one of these batteries, plug it into an external charger, it'll happily start charging again. So this battery's been charging for a while now, so I'll just check the voltage using the test points on the charger. As you can see, we're now getting 3.8 volts, which is in the standard range for a lithium-ion battery. This battery can now be put back into the controller, and hopefully it should work correctly. I want to try and feed these battery wires through as they were originally, which I think is going to be a little bit fiddly to do. That was a lot more hassle than I'd expected. I'll probably end up editing some of that out. But it is fed through now, and now I'll just solder the wires back in. And then I should be able to put the controller back together. Took a while to get that back together, but in the end this has been a pretty straightforward fix, and it's always something to look out for if you've got a wireless controller that's showing signs of no power. It doesn't always need a new battery. I hope you like this video. Thank you very much for watching, and be sure to stick around for the next one.